So if you're new on this stream and you like to learn why this guy does this thing, it's just simply for the entertainment purposes. I like it. I like creating content, and this is a content about my profession, also I think a hobby of mine, which is software coding, whatever you might call it. And today I'd like to start with a Leetcode question. It is for practicing the problem solving skills and also preparing yourself for the worst case scenario, which happens in a market that is not well. I think it's okay right now, but so that's the lead code part, and then I'd like to perhaps I'll move on to my personal project, which is 1 million checkboxes. I'd like to um, develop something from start to end. I will get help from Cursor, but I'll be more careful right now not to accept everything and try to make it proper. And perhaps we can deploy it today, which will be a new experience for me because as a software engineer, I have 3 years of experience on the backend systems, and most of the systems are laid out by the previous engineers. There's a working product, the pipelines, infrastructure. It's all ready. But if you like to develop something from start and deploy it, it's a new experience that you can probably collect with side project like this. Yeah, and you can then take a look at how your at work your pipelines are set up, just to understand what's the benefit there. So it will help both ways, I think. Okay, then I'll stop talking and I'll make this like this, and we'll start with the lead code question. Perhaps I can continue on this one. It was not optimal yesterday. Um, sure. The trick here is this one, making it O1 time complexity. Yesterday I submitted it and it worked, but it's not O1 time complexity. This first two, basically initialization, then inserting and removing, is very straightforward with the help of just a set data structure, which is access and deletion is O1, right? But in get random, we'd like to, let me describe what I've done. So I had a look at how long, how big is my set at this moment. And from this set, I'd like to choose an element randomly, right? And if you like to return something from an interval, you actually decide on an index first, and then you use that index to return the value back, right? And here I do that. I generate all the indices of of this set. The set doesn't have indices though, but it's just I'm imagining it as a list, right? And then I'm casting it to a list, and then I'm randomly choosing an index, and then I'm returning it from the randomized set, right? So this is O and time complexity. The reason of that is this line specifically. When you typecast it, it's basically, okay, I think it's clear. So let's move on to the optimal solution, which I don't know at the moment. So from a set, you'd like to have randomly choose something, right? There are some constraints, some values. Oh, by the way, today I think we have a contest. Okay, it's on. Wait, what? In next week. Okay. So these are the values for each item in our randomized set, and this is at most that much time. Time. This call we will call the insert, remove, and get random. There will be at least one element in the data structure when get random is called. Okay. To be honest, maybe this is more for statically typed languages, um, and maybe yeah for C++, whatever. Maybe you need to have better data structures, but not sure for that. I don't know what information it brings to the table, but I can understand that this is also for the error handling of probably more strictly typed languages. Um, yeah, or maybe random choice doesn't do anything if it's like a empty list. Maybe it's raising error. I don't know. I can understand the background of it, but yeah, I don't have an actually new information from here. I need to just optimize get random. Easier, easy to be said. What's the yeah, okay, I'm waiting. Okay, this is our list. We'll randomly select something, some value from here. Okay. So the bottleneck is here, right? You you don't want to typecast it, but somehow be able to access a random index here. Or yeah, maybe I need to store some additional information here other than the set so that I can access it later on. I thought about like having a randomized list, right? And it will insert the values, but hmm, okay, that's not good as well. I think I'll get a hint which doesn't exist. That's bad. I mean, you have a set, and you should be able to, I don't know, have something that works like that. I'd just like to have a look at the Python set documentation. Um, what is this? Python basics? No, it's something else. Python set documentation. I think it's here. Set. Is it all that you have? Set. I think so. Is it Wikipedia? No set types. Mm. Do you have peak? No. I think this is the answer though. You will pop an arbitrary meaning, is it random? Not so sure though. Um, yeah, arbitrary doesn't mean random. Random is more strict, but the thing you can do here, you can pop an arbitrary element and then add it into the set later on, but you will just return the value of the popped element. So it should be very easy right now. Self.randomized set pop, and it will be the value, right? Result, or not result, but like random value, and then you will return random value. But before that, you have to edit back, right? Um, you can just call self.insert random value. Um, so it should be right now very fast. So we got the wrong answer. Hmm. Wait, true. One. Wait, what? Randomize set. Insert 1, insert 10, insert 20, insert 30. Get random. Maybe the test case is set up in a way that it overrides random, and yeah, I don't know. It should have worked. I don't know. I'm missing something. Can I have a look at the discussion? Just, I don't know what that is. Hmm. All right, I think I got it. So it basically says, um, I don't know what that is, but I think this is answering my thing. So you'll have this randomized set, but also you'll have um, all yeah, just all elements, right? You can have all values, and it will be a list. And when you're inserting it, you can say also append it to all values. And when you're um, removing it, then you won't do that. Wait, no, no, no. No, 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 no. Come back, come back. You can't just typecast the set to a list. You should have it.
Your wallet sucks. One, welcome back, and let's write some more neat code today. So today, let's solve the problem insert, delete, get random, all in O of one time. So as the problem says, we're basically implementing these three methods, and we want to design them in such a way that we can do all these operations in constant time. We're given a single class. It's called randomized set. It has a constructor, which we can use however we want, and it has three methods that we need to implement: insert, so which is just as it says, we're inserting a value. If the value though already exists in our set, then we're not going to add it twice. But if it doesn't already exist, we're going to return true from this method. If it does already exist, then we return false. The other method, remove, is similar. We can only remove a value if it's actually present in the set. And if it is present, we remove it and return true. If it's not present, we just return false. The more interesting method is get random. Basically, is supposed to return a random value of all values that are currently contained within our set. We know each value in the set is going to be unique, and when we return a random value, each value has to have the same probability of being returned. So I'm going to take you through the thought process of coming up with a optimal solution for this. It's pretty tricky in some ways, though, but I think it's also intuitive once you understand it. So this problem is pretty easy when you just take these two methods in isolation. So inserting a value and removing a value in constant time is pretty easy when you have a data structure called a hash set. And the hash set will actually be even more helpful because we'll also be able to know in O of one time if a value already exists or if it doesn't already exist. So rather than using a list and searching through that list, we can check that in a hash set pretty easily, and then we can return true or false from either of these functions, depending on the result. So I think the simple answer for these two methods is literally to just use a hash set. But the problem comes when we get to the third method, the more interesting one, get random. Getting a random value isn't very easy, especially with the exact same probability. Even built-in functions can't do it perfectly, but that's exactly what we're going to do. We're just going to use a built-in function to do that. The easy way to get a random value, suppose if you just had a list of like 3 elements or something, you just take the indexes 0, 1, 2, and then from these indices, we would generate a random value that is within this range. And you can use some like standard built-in Python function or Java or whatever to do that. But the problem is we would need the indexes, right? We would pick a random index and then, suppose the random one would be this one, then we'd get the value at that index and then return it. So this is the random value we would return. But we can't really do that with a hash set. We can't index a hash set. Hash sets are unordered. When we generate a random value, it has to be of a continuous range like this. I mean, we technically could convert the hash set into a list, but that would take O of n extra memory. So what we're kind of realizing here is we can't just maintain a hash set. We also have to maintain a list at the same time. So every time we add a value to our hash set, we also add a value to our list or array. So in that way, getting a random value will be an O of one time operation. I'll show you how to do that in the code. In Python, it's pretty easy. I think it's pretty easy in most languages. But now, actually, the problem might be a little bit subtle. So let's take a look at an example. So we're actually going to go through our own example rather than the one down here. But let's say first we wanted to insert 1. Then we would, very simply call our insert function. We would check is 1 in our hash set. We can do that in O of one time. It's not in our hash set, so we add 1 and we add it to the end of our array, which is currently empty, so we can just add the 1 over here. Let's say next we want to add a 2. Oh, and by the way, we return true from the insert function. And obviously, if we wanted to get a random value right now before we insert the 2, there's only one value in our list. So when we generate the index, of course, it's going to be this index 0, and then we would return 1. So pretty straightforward. Next, we add a 2. We do the exact same thing. We add it, we check if it's in our hash set. It's not. We add it, we append it to the end of this list. Now, if we wanted to add 1, in this case, we check, is it in our hash set? Yes, it is. So we don't add it to the hash set, and we don't add it to the list. If we wanted a random value, we would look at the two values here. We generate a random value between 0 and 1 because those are the indexes of these, and then we return one of them, whichever one gets returned. Now, if we wanted to remove 2, for example, first we check, is it in our hash set? It is, so we'd pop it from the hash set, and then from our array, we would just pop 2 from the end of the list. And then if we wanted to get another random value, we could just get this one. We would take the length of the array and generate a random value between the valid indexes. Now, that was easy because in that case, we removed the value from the end of our array. But what if we were actually removing a value from the middle of our array? What if we were actually going to remove 1? And to actually demonstrate this even further, suppose it actually was a value in the middle of our array, suppose it was 2, then we'd have to do something like this. Now, how do you even remove a value from the middle of the array? Don't you have to shift everything else over? And if we do that, then it's an O of n time operation. So the problem we discovered is if we have a list and we have a hash set, we can do everything efficiently except for the remove operation, which takes O of n time. Is there a better way we can do this remove operation with these given data structures? The first thing is if we were removing 2 from the list, we don't even know what index 2 is at. We literally have to search through the entire array to find 2. We know for sure it exists from our hash set, but we don't know where it is. So how about one change we can make I erased the set part because now we're actually going to be using a hash map. We're going to be mapping each value that we inserted to the index that it was inserted at. So in this case, 1 would map to 0, 2 would map to 1, 3 would map to 2, etc., etc. So that's one part of the remove function. Now, if we wanted to remove 2, we know exactly where it's at. Can we just kind of erase that value? Can we just set it to a default value of 0 or something? Not really, because then if we generated a random value, what if it landed at this spot? How about we replace another value with, we basically move another value over here because we know 2 does not exist anymore. How about we take 3 and add it over here? That kind of works, but now the problem is if we generate a random value, 3 has a disproportionate chance of being selected, right? Each value is supposed to be unique, but now we have 2 copies of 3. So what should we do? Well, remember we could remove values from the end of the array in O of 1 time just by popping the last value or just saying, okay, this value doesn't exist, the size of the array is smaller now. So how about a clever way that we can handle this is taking the last value, copying it into the index that we're removing from, and then popping this value. Because now we are left with an array of size 2. We remove this value, and then if we want to generate a random value, we don't consider this position a valid index anymore. We just generate from these two. They're contiguous, and we can generate a random value. We accomplished our exact goal. We did all of this in O of 1 time because we didn't have to shift the entire array over. We only had to swap the one value in the array. Oh, and one thing don't forget to do in the code is then update the mapping in the hash map. So 3 originally mapped over here, but now it should map over here. So using these kind of tricks, we can implement all of the methods in O of 1 time. So now let's code it up. Okay, so now let's code it up. Remember we have two.
Okay, let's go over it by ourselves. There's X, yeah, this one I think, right? You already have it for another example. But yeah, let's go here. And I will just write it down. So let's have, we'll insert 1, then insert 2, then insert 3. So these are the inserts, and we'll delete, and this is the time, okay? So this was the one. Okay, and here we remove 2. Perhaps we can do another 2 here, okay? Just to have this. And then random operation at here, okay? So we like to first store that, so this will be our dictionary, if you like. It's hash map, and also we'll have the array, and it's this. I'm not sure if you're able to see it right now, but to start with, first this one comes, right? We put it to our dictionary and also to our array as it's not there, and we say this has an index of 0, and then we move on to here, 2. So 2 comes and we write it to our dictionary, and it's uh, it's supposed to come here. Its index is 1. And then there comes 3. Sorry for this, but yeah, it's this. Sorry, it's 2, right? The index of that is 2. And then you write 3. And there comes 2 again. But 2 we see, oh, it's already in our dictionary, which means you don't need to insert it into our array. Then you see a deletion for 2. You check, oh, it's okay, it's there. We should remove it from our array, because we'll at the end we'll use this array to do the randomized checks. Okay, so you check which index is it. Oh, actually, it can be not a list, because on our array they will appear once, right? But anyway, so it will remove the 2 from the list. It will see, okay, it's the index 1. It will remove it from here, and it will put 3, which was the last item, back here. And then you will randomly choose an index. Yeah, I think so. The randomly choosing the index, I don't know what we'll do. I think, yeah, we already have our list, so it will basically be random choice self all values, right? Yeah, that's it. Let's code it up. So this will be a dictionary, and you'll also have all values, which is a list. Let's make it fancy. Whenever we insert, we will append it to our list. But I need to change these things, right? This is randomized set. Actually, we should rename it. Maybe let's start from the start. So it will have the first these indices information. The keys are values to indices, I would say, is a good name. And the other one will be all values. It will be a list. In insert, we check if val in already in self values to indices. Right, it will do this check on the keys of this dictionary, which is what we want. We'll just return false. But if it's not there, we'll add it, right? Value, and the index of it will be what? So we'll basically append it like this, and then we need to, after appending it, we need to learn what's the yeah, it will be the last index of our array. I forgot here that once you do this change, popping out and replacing it with the last item, you have to change the index here as well and make it 1. It's a bit ugly, but it will make sense in the code right now. In the remove, if valid not in self values to indices, so if it's not there, it will again return false. But otherwise, we will do the following. So we'll Okay, this is not a randomized thing, but we'll do the, okay. First, you like to remove this value. So you have to check what's the index for this value, right? Um, Once you have that, you will access this element, right? And you would like to exchange it with the last item. Um, I think it will work like this. Pop will pop the latest item from the list, and we will put it back to index. So it will be, so here it was the following. Let's have this color. So our hash map is 1 our hash map 1 and 3 is, sorry 2 is 1 and 3 is 2, and at this point our list is, all values list is 1 through 2 3, and if you'd like to remove 2 here at this timeline, we'll remove it. We'll check which index is it. Okay, it's in this index. On this index, now I want to replace it with the value that I will pop from the list at the end of it. So it will become 1 and 3. And this one should go as well. You have to pop this thing out, remove a key from a dictionary. So first things first, you got the index, you updated this index value, the value on this index, to the latest one. Now, actually you also need to learn like what was the value of this, right? But you already have it here. So you, maybe you can you can put it like last value just to make it clear. And last value, sorry, you have the index. You pop the last value on the list and you put it to this one, and you have to update the values to indices for this last value to the new index, and then you will return true here. I forgot to do this here as well. Okay, so if you want to remove a value from your randomized set, you are first checking if it's there or not. If it's not there, return false. If it's there, learn the index of this value on your all values list. And after having that index, pop the latest element from the list and put it to that index. And yeah, but actually you have to also like remove it, right? Python said, I think like remove should be should be possible. You have to also remove it from the here, and remove and key value here should work it, solve it. But I don't think it will return it back here. So let's make it a bit more long, but it will be okay. Okay, the random is just let's import random here. Doesn't matter. Random.choice, self, all values, and you'll just return it. So this is O1. Is it like delete? Python dictionary remove key. Delete, yeah. Or we can do pop. I think, yeah. Let's have this thing. You do this, right? And key. So this is O1 time and O. Okay, so the value that you, here is the case. It removes first 0, it removes again, it then inserts it, it calls get random, and then removes 0 and then inserts it again, right? And probably when you remove this value after you insert it, this it was actually the last value, right? If it were the last value, there's nothing that you can do here. All right. I think you have to check like if all values has a single value size. You have to you don't need to do this assignment of the last value thingy. You can just you already removed it, so you'll just, yeah, basically you'll pop the latest item and that's it, which is the one that you're removing actually. So, and return true. We'll have all this kind of the rest of the magic stuff later on. What's wrong? List assignment index out of range. Insert 0. Delete 0. What happens? You put this 0 value to our hash map, and also you put this into the array. Then you have delete 0. You will first say, okay, let's have the index, it's 0, and pop this element back from here. It will be empty list. And then let's pop this thing from here as well, and that's it. But I think for the last item, it's a bit tricky, more tricky situation. When you insert 1, insert 2, delete 2. Now what happens? Now you have 1 is at index 0, right? And then you see insert 2. So 2 has an index 1 because we put it here. And then delete 2. You first get the index, it's 1. Remember that it's 1. Then remove this from the list, hash map. And for this index 1, go and have a look. You pop it and you put it to the new index. So if you pop it, the problem is the size of the array is reduced to 1, which then you can't directly access to that index, which is what we do here. So you have to check probably not this, but if the value that you're popping is the latest item of the all values. I think that's the thing. Because if it's the latest item in here, you don't need to do this magic, like not magic, but like this transformation. You just have to pop it. That's it. No more thing. So if the so here, if the value equals to the self all values, the last one, you just have to pop it up from there, and that's enough. Um, Otherwise, you have to get this number, you popped it, and then you have to put this, like, yeah, whatever values. You have to check out the index of it. Basically, you will write it back, um, but it's last while, right? So if it's not the case, you have to. So what you do, you get the index, and then you pop the from the dictionary, and then from that index, you you write the last. You pop the item from the end of the list, and you write it back here. This last value. And then you have to update values to indices for this last value to this new index, and then just return true. Okay, now this is a proper solution. So the space complexity, I would say, because we are storing these values, and since we have this O1 get random uh, requirement, time complexity requirement, we are storing this additional storage which has n element, so it's On space complexity, I would say, um, and the time complexity will be O1. Yeah, these are all O1 operations. I don't know, like this, popping, accessing to indices, deleting from a hash map, key from hash map, and this is also one. Yeah, I think that's it. That's the proper solution of this question. It is, if I reflect back on my experience of this question, it's just very humbling experience, especially on a stream that you make it very transparent. It's a bit difficult to accept. I expect myself to perform better, and probably which is the case for everyone, right? But it's the learning process, so it's also a humbling process. Um, I think I rush to the solution within the streams to um, because it's more comfortable to the rushing up to the solution. But if you like to work on the optimal one, there it gets a bit uncomfortable and difficult. And that's what I omit. But I think this time, even though I watched the question solution here, I haven't looked at the implementation. I took the time to explain, understand, but still I could have done better. This is still, I don't feel 100%. Um, it's not just a minus operation that I can do in my head, right? So probably it will take time, but I just loved doing the visuals from here. I think I will continue doing that. I don't know what's going on. All right, it's time to end the video right now. Maybe I'll continue later on. Uh, Not with a lead code question, perhaps. I don't know, maybe lead code again. But yeah, it's time to end it right now. I don't see any URLs in the chat, which is probably makes sense, right? The language of this video is Python. I don't know. It's maybe it's not very. All right. Have a nice day.